All right, so let's continue looking at applications of linear systems. Question 3. Erin spent 30 minutes on the rowing machine and 20 minutes lifting weights at the gym and burned 430 calories. During her next visit to the gym, she spent 50 minutes on the rowing machine and 10 minutes lifting weights and burned 600 calories. How many calories did she burn for each minute on the rowing machine? How many calories did she burn on each minute of weightlifting? All right, so we're going to use the last two questions to help us to define our variables. The second to last question says, how many calories did she burn for each minute on the rowing machine? And then we have, how many calories did she burn for each minute of weightlifting? So my variables are just each of those quantities. X, calories per minute on the rowing machine. Y is the calories per minute weightlifting. So now we could use these two variables to write two equations. We know the time she spent on each item at each visit at the gym. So first she had 30 minutes of rowing, so it's 30 times X, plus 20 minutes weightlifting, plus 20Y, and she burned 430 calories in total. So that first statement translates into the following equation: 30x plus 20y equals 430. The second statement, during her next visit to the gym, she spent 50 minutes on the rowing machine, so 50x plus 10 minutes lifting weights plus 10y, and she burned 600 calories, so equals 600. So now we could go ahead and solve this system of equations. You can decide to use substitution or elimination. Because of the way that these two equations are set up, and because of the coefficients, I'm going to decide to use the elimination method. You can decide to eliminate x or y. I would prefer to eliminate the y here because 20 is a multiple of 10. I can make this coefficient the opposite by multiplying by -2, and then doing the same thing on the other side. The first equation is going to stay the same. 30x plus 20y equals 430. The second one is now -100x minus 20y equals -1200. Now I'm using the elimination method, so I want to add these two equations together. The y's cancel. I have -70x equals, go ahead and subtract those. So I have -770 here, and then dividing by -70 on both sides. And I have x equals 11. Now, if I'm thinking about reasonableness, remember that we would expect our answer to be positive in this case, so you make sure that your answer does agree with that. So x is the number of calories per minute rowing, so it's 11 calories per minute. And if we want the calories per minute weightlifting, we have to go back to one of our equations. I will go with the first equation. 30x, let me replace x with 11, save some space, plus 20y equals 430. Multiplying 30 times 11, 330, plus 20y equals 430. Subtract 330 from both sides. 20y equals 100, and then dividing by 20. So y is equal to 5. So 5 calories per minute weightlifting. So we've answered the question by, filling out the variable in advance, and there we know that we've answered the question. Let's take a look at number 4. All right, so here we're looking at some geometric applications. Two angles are complementary if they add to 90 degrees. If the difference of two complementary angles is 20 degrees, find the measure of the angles. All right, so we want the measures of both angles. So let's let my variables be the measures of each angle. So x will be the measure of the first angle, and y will be the measure of the second angle. Now, the fact that they are complementary gives me one equation. So the first angle plus the second angle has to equal 90. So let me show you what I'm writing here. So I define my variables. X is the measure of the first angle. Y is the measure of the second angle. And because they're complementary, x plus y has to equal 90. So that's given by the fact that they are complementary. Now the difference of these complementary angles is 20 degrees. So the difference of these two numbers, whatever they are, is 20. So x minus y is 20. It doesn't matter which one I put first, x or y here. By putting one in one particular place, I'm automatically now making x the larger of the two angles, because when I subtract, I want the difference to be positive. But that really doesn't make a difference which one you call the first and which one you call the second. So this is set up very nicely to do elimination because the y's are already opposites in coefficients. So I'm going to add these together, 1 and 2. The y's cancel. So we have 2x equals 110. Divide by 2, and I get x equals 55. So the measure of my first angle is 55, and I could use either of these equations to get the other missing variable. So if I have the first one, 55 plus y equals 90, well, to get the y, I would have to subtract 55 from both sides, so I would have y equals 35. So if one angle is 55, the other is 35, and those both add to 90 and have a difference of 20. The next example uses supplementary angles. Supplementary angles add up to 180 degrees. 180 degrees is also known as a straight line. So sometimes these angles are called a linear pair. Given two supplementary angles where the larger angle measures 18 degrees less than twice the measure of the smaller angle, what is the measure of both angles? All right, so in this case, our variables are going to still represent the two angles, but now I'm told that one is smaller than the other, and they are supplementary, so that gives me one of my equations right off the bat. All right, so I wrote my variables out already. X is, I started writing larger angle, but then I've said, let me be really careful here, right? Because variables represent quantities. So I went back and I filled in X is the measure of the larger angle, Y is the measure of the smaller angle. And then from the statement that they are supplementary, I have my first equation, X plus Y equals 180. But now I want to go back and write the second equation, which gives a relationship between the larger and the smaller angles. So we're told that the larger angle measures 18 degrees less than twice the measure of the smaller angle. All right, so the larger angle is 18 degrees less than 2 times the smaller. So let's write that out. The larger angle is, so my larger angle is x. X is 18 degrees less than twice the measure of the smaller angle. So again, we see that less than, so change the order of your subtraction. So these are my two equations. This one leads me towards substitution because my second equation is x equals. So I'm going to substitute this expression for x into the first equation. All right, so we have first equation is now 2y minus 18 plus y equals 180. Combining like terms, 3y minus 18 equals 180. Adding 18 to both sides, 3y equals 198. And dividing by 3, I have y is equal to 66. just double check my division there. 198 divided by 3. Just don't want to make any mistakes. All right, so that is 66. So y is the measure of the smaller angle. And this would be in degrees. I'm going to put my degree symbol here. Then the larger angle I can get from either of my equations. I like the first one. A little less work. X plus y is 66, so x plus 66 equals 180, which means to get x I have to subtract 180 minus 66. Let's see, 180 minus 60 would be 120, minus another 6 would be 114, and that's in degrees. So I found the measures of the larger and the smaller angle in that situation. All right, question 6. Mario wants to put a fence around the pool in his backyard. Since one side is adjacent to the house, he will only need to fence 3 sides. There are 2 long sides, and the one shorter side is parallel to the house. He needs 155 feet of fencing to enclose the pool. The length of the long side is 10 feet less than twice the width. Find the length and width of the pool area to be enclosed. Right, so I went ahead and I drew a little image of what's happening here. So this is the house. So we're told that we're only using 3 sides. So it's not 4 sides of a rectangle, it's just 3. And you're told that the shorter side is parallel to the house. So we're finding 2 lengths and 1 width. Now I'm using the variables L and W to represent the length and width. And I know that for a rectangle, it's usually twice the length plus twice the width, but now I don't have 2 times the width, right? It's not a full rectangle. So this would be the relationship that we have. We're told that we had 155 feet of fencing. So that formula now turns into 155 equals 2 times the length plus the width. 155 equals 2L plus W. But we need another equation, and there's another relationship that we're given between the length and the width. We're told that the length of the long side is 10 feet less than twice the width. So the length of the long side, L, is 10 feet less than twice the width, so 2W minus 10. So we now have 2 equations. First one was from the perimeter, right? Perimeter is adding up all sides, and the length is 10 less than twice the width. So once again, I'm going to use substitution, and let me take a moment, speed ahead, and write that substitution for time. All right, so I went ahead and made that substitution. You can pause and double check if you're unsure. Now I'm going to go ahead and solve this equation by distributing this 2 and then combining like terms. I'll go ahead and add 20 to both sides. Write that over here. So 175 equals 5W, and then dividing both sides by 5. So I now have 35 equals W. So that means my width is 35, and I was asked to find both. So let's see, I could use either of my original equations to find the length, but since I am looking for the length, I'll use the second one. Let me fit this in here. The length is 2 times the width, 2 times 35 minus 10. So my length is equal to 70 minus 10, or 60. And this was all in feet because the perimeter we were given was in feet. So that means the length should be 60 feet, and the width should be 35 feet.